Ignite, fly, stage, steer, and you're in space. But once you're out there with nothing to push against, how do you move a rocket? The answer? Ion thrusters. But first, chemical propulsion gives a massive kick. Perfect for takeoff, but painfully inefficient when you're in space. Out here, every kilogram of propellant matters, and carrying more is just not an option. We need something smarter. This is where ion thrusters come into play. They don't burn fuel, they use electricity, usually from solar panels, to accelerate charged atoms. Instead of seconds of fire, they push gently for months, sending spacecrafts millions of kilometers away. Now, how do they work? Well, inside the thruster, xenon gas is bombarded by swirling electrons, forming ions. These ions are pulled through an electric field and shoot out the back at up to 40 kilometers per second, almost 10 times faster than the exhaust of a chemical rocket. Finally, the atoms are neutralized by a stream of electrons, so they don't get pulled back towards the spacecraft. Now, in an ion thruster, the thrust comes from converting electrical potential energy into kinetic energy. Higher voltage means faster exhaust, and that's what we call efficiency, getting more momentum change per kilogram of propellant. Ion thrusters are up to 10 times more efficient than a chemical rocket, but that efficiency comes at a cost. Each ion has a tiny mass, so even when moving extremely fast, they produce very little overall force. For example, they're not useful for takeoff, but in the vacuum of space, they become incredibly important. That's how missions like Dawn traveled over 6 billion kilometers, not with brute force, but with precision, patience, and the light touch of a few ions.